So I'm going to go ahead and divide by b on both sides. And that's going to give me y minus capital A over capital B is equal to 1 minus e to the negative c to the x power. And now I'm going to bring the 1 over. So that's going to give me y minus a over b minus 1 is equal to e to the negative cx power. Oops, sorry. Here. All right, let me ask y'all a question. Is there anything else we can do to maybe make it a little bit easier on ourselves?
Get rid of those negatives.
Get rid of that negative. How?
Multiply by -1.
Or divide through by -1, whichever one you want to do. Same thing. So I'm going to divide by -1 or multiply through by -1, whichever one you want to do. And that's going to give you, I'm going to put parentheses in front of this. That's going to be negative y minus a over b plus what? 1 is equal to e to the negative cx. Now at this point, you've got it to where you can solve now, but all we've used is nothing but what? Algebra. Now, I want to bring this downstairs. So I'm going to have to use log base 10 or natural log. Which one am I going to use? Log base e, which is what? Natural log. Get used to doing this, especially in differential equations. Okay, because when you do this, when you take the natural log of e, basically it's what? 1, and this comes what? Comes downstairs. Yes, sir.
Is that negative right there?
Right here.
No, right here. I don't know. Y right there. Are you gonna like distribute that at all?
You can. I'm not worried about it right now. You can. It'd be a minus y. Yeah, a minus y over b, or y minus a over negative b, whichever one you want to do.
And like when we write these on a test, we kind of use all the brackets and stuff.
Well, the only reason I did this was because you're taking the natural log of this right here. So you might want to put, brackets right here, because you got to remember, you're not just taking the natural log of this, you're taking the natural log of the whole thing. Okay? And that will be cx. So that cx is going to come down, so you're going to get natural log of a minus y over b plus 1. How does that look? Does that look a little bit better?
Yeah.
Hmm?
Yes.
It's still nasty looking, but it's better than that top one. Okay? Equals negative what? Cx. And what are you going to do with it? Is that a capital C?
Yep.
Does that make a difference? Oh, yeah. And what are we solving for?
X.
So divide by negative C. Because in science, a capital C is different from a lowercase c. That's your answer. Now, of course, you could take that negative and you could work it in here, but I just leave it like this. Once you do one or two of those in your homework, you'll see how they run. Now, where is the logarithms? The last step. The last step right there where I took the natural log, that middle step right there is the only logarithmic rule that you had to do. And this is just like calculus, because in calculus, and especially in Calc 1, there's only 10% calculus with 90% algebra in each question. So you're getting a good taste of it. Let me go ahead and get that drop slip ready. And quit, right?
Too late for that?
No, it's never too late to quit. You can quit anytime. All right, and that's solving equations, pretty much. Okay, when you see one like this, when you see any like these, what's the first thing you should think of? Rewriting with terms of what? An exponent, yes. Anytime. That's just a little information I'm looking to see. All right, here's where you get into your exponential growth and decay. Now, this is important because of you science majors. Some of you science majors, you're going to be seeing this for the next 3 or 4 years, where a lot of engineer and math majors see a lot of, well, engineers, you see your calculus, but you also see your first and second calculus, and you keep on seeing the first and second calculus in statics and dynamics and physics and blah, 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 blah. With science majors, they see this exponential growth and exponential decay all the time in all of their courses, because a lot of times they're especially decay, they're figuring out how long something will last when it rusts, when it that's all they. Business, any of your business majors, you're going to be exponential growth, because you want a business major wants to be able to figure out when something's going to die out or when it's going to speed up. You know, dang old stock exchange, all that kind of stuff. All right, I'm not a business major at all. No, never. I couldn't sell an Eskimo a heater, but some people can. Okay, and those are your business people. And that's what these are. So you need to write down a sub o e to the negative kt and a sub o e to the kt. You need to write those down. There they are, right there. Write those down and make sure you understand the definition of the two. The one with a positive exponent is exponential growth, which is business, which is a lot of business applications, versus the negative exponent, which is the one you don't want to see in business. Why? It means you suck as a business is what it means. It means you're losing money. So we don't want to try to work that into our business model. And there is the actual graphs of the functions. I'm not going to spend a lot of time with that. One is good, the other one ain't so good. You ever heard of the term half-life?
Yes.
Half-life is negative, that's your negative. Usually talking about dang old radioactive, dang old stuff to make you turn green. All
It's
right?
defined as the amount of time that it takes for half of a substance to decay.
That's it. Dang old science major. All right? Finding the age of a fossil. That is called carbon what? Carbon dating. And dang old, you'll see, this is the type question you'll see on a standardized test. Whether it's the SAT test or whether it's, for some reason, they love putting these on those tests. So, not that you're gonna get another, SAT test, but just take a note, and just carbon-14 is a radioactive form, radioactive, meaning half-life, that is found in all living plants and animals, blah, 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 blah. Using a technique called carbon dating, scientists determine the age of remains by comparing the amount of carbon-14 present with the amount found in living plants and animals. The amount of carbon-14 present after T years is given by the exponential blah, 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 which is your decay. With K is equal to that. The half-life of carbon is 5,700 years. If a fossil contains 1/5 of the carbon contained in a contemporary living sample, estimate its age. So 1/5 of the carbon is there. So 1/5 is the same thing as what? 2/10? 0.2? I think it's 0.2. But you don't have to do that. And you start off with, right there, they give you K. And then there's the 1/5, which is the carbon dating at the beginning. Or the amount of carbon, plug and chug. And you end up basically taking the log of both sides because you have something in the exponent. What do you have in the exponent? What do you have in the exponent? Excuse me. You have T. And what is that? It's a variable soluble. So you plug and chug and take the log of both sides. And why are we taking the natural log? Because it's E. Thus, anytime you have a business model or anytime you have a half-life or a decay, are you going to use LOG or are you going to use natural log? You're going to use natural log because it's going to be E. If it's that decay or business model, it's going to be E, so you use natural log to take the natural log of both sides. Okay? And this is your given half-life. Half-life would be 1/2 the initial. Right there. So you have to throw that in there for half-life. Will it say half-life? Yeah. Okay, it'll be half-life or some kind of form of half-life. Okay, let's talk about this guy. Write that one down. That one's another one. Very important application. Why is this one very important? Because all of you are going into business. Is that why it's very important? I have to wait a few minutes. I'll go ahead and write it. And I think that on board either. Oh well. Let's see if I can make it come on. Anybody see that light? Is there a light up? It's orange.
Yeah, it's blinking orange.
I was hoping it'd turn green. It should be green now.
Yeah, it's green.
All right, we in business. Because everybody's going into business, right? That's why I need to show you all that. No, because anytime you're dealing with a bank or you're dealing with somebody that's charging you interest, charging you or giving you interest or charging you interest based on if you're buying or if you're saving, you're going to be using some form of, it's not coming on. I knew it was. I'm never that lucky. There, now it's on. Now it's on. And that is A is equal to P times parentheses 1 plus R over N raised to the NT power. This is one of those formulas that I don't care whether you pass this class or not. It's something that you need to be aware of because it's going to apply to you whether you are using a credit card or whether you are saving money in the bank. Yes, sir.
What's the outside of the parentheses on the right side?
NT, raised to the NT power. N times T. I'll tell you what all that is in just a second. Well, let me just go ahead. I'm going to go to this page. Let's hold on. A is equal to P times 1 plus R over N raised to the NT power. Ma'am? Mm-hmm. Yes. How'd you know that? Did you? Mm-hmm. Well, a lot of your math courses have this in it some way, some form. Because, like I say, it's not only applicable to compound interest, it's also applicable to exponentials as well as you could apply calculus to this also, area under curve. But anyway, area, this right here is going to be your outcome. This is the number of dollars that you have at the end. I'm not going to worry about this. This right here is what we call the principal. If I can remember how to spell it. P-A-L is like the principal. It's called P-L-E. I think that's right. P-L-E. Principal is what you put into the bank. Like if you open a savings account and you put in $500, then $500 would be the principal. R. R is rate. And it's usually going to be given in a percent. Do you use percent like that? No. You change it into a decimal. So R will always be calculated as a decimal. So if it's 5%, it would be 0.05. If it's 2%, 0.02. Okay? N. N is equal to the number of times your interest is calculated. Now, a 25-cent word for calculating interest is compounded. Meaning that if you have a bank, John A. Smith Bank, and John A. Smith Bank, you put your $500 in that Smith Bank, and they compound it 12 times a year. That's monthly. Then that means the computer at John Smith Bank, whatever their server is or whatever, it goes through and gets every account number, finds out what the balance is, and it calculates, boom, calculates that month, throws the money back in there, or throws that number back in there, throws that number back in there. Goes down each one of the accounts and does that. Then the next month, it does it again. Same day, same time. Next month, it does it again. So if it's done monthly, N is equal to 12. So let's write some of those down. If N is equal to 12, that's monthly. So in the problem, it would say compounded what? Monthly. Well, what if N is equal to 4?
Quarterly.
Quarterly. What if N is equal to 1?
Annually.
Good. What about N is equal to 2? Semi-annually. I'm so proud of y'all. I bet y'all can make change. All right, semi-annually. That's what it goes. You ever seen people can't make change? You give them 6 cents. Their head explodes. What about daily? 365. Weekly? 52. Notice, what do these all have to do with? What do all of them have to do with? Time? Yeah, that's not what I'm looking for. Number of times interest is calculated, I should put this, throughout the what? Year. 12 monthly, that means a year. Annually, semi-annually, compared to a year. So, T is always going to be written in terms of years. Time, money, time principal is kept. And 99% of the time, it's going to be in respect to what? Years. So if I tell you that you kept your money in the bank for 6 months, what would T be? Huh? Be 0.5. Okay? And there are questions on tests and homework. I'm not saying this homework. There are tests that will say, you keep your money in the savings account for 6 months. It's compounded monthly. So N would be 12 and T would be 0.5 or 1/2. Because how many years did you keep it in the bank? Huh? Half a year. 6 months. So let's say that I was going to give a example. Hold on just a second. Let's say that Mr. Pruitt wins the lottery. Okay? And Mr. Pruitt gets a check for $5,500,000. Is that good enough for you, Mr. Pruitt? Since we're, dreaming, might as well dream big. 500,000. And he does what most people do. He goes out and buys 2 or 3 new cars. He goes out to do this guy in Texas did. He goes out and put $500,000 worth of cash in each of the consoles. And what happens to the cars?
They get stolen.
They get stolen. Okay, so that's what Mr. Pruitt does. Right, Mr. Pruitt? No, hopefully, before he decides to do anything with this check, he would put it in the bank. Let's say, the first redneck is going to say, well, I'm turned up, put it in the bank, I pay all my bills off. Listen, if you put $5.5 million in the bank, are you going to have to worry about any more bills? The bank will pay your bills for you, okay? If you put $5.5 million in that bank, the president of that bank is going to come over to you and say, oh, we'll take care of your bills. We'll take care of them. We'll fix a loan, pay all your bills off. You just put that money in the bank. You leave it in there for a couple of 5 or 10 years. Well, I want to buy a car. We'll take care of it. Why? Why will they take care of everything? Y'all don't have any idea? Huh? What are they going to do with this $5.5 million while it's sitting in the bank?
Loan it out.
They're going to invest it. Okay? You're going to make, of course, 2 or 3%. Mr. Pruitt's going to make 2 or 3% off of it. Okay? He's going to make that. It's going to go back in. But what are they doing with that $5.5 million while you're sitting there and be safe? They're investing it. Okay? They're taking 500. They'll take, let's say, $1 million, and they'll buy $1 million of penny stock. Well, of course, they're not going to buy penny stock. They're going to buy stuff that they know is growing. And then they keep it. They buy that $1 million worth, and they keep it in there for 2 or 3 months, and it makes $200 or $3 million, and they put it back in the bank. They sell the stock, put it back in the bank. That's what the banks do with your money. All right. And if you didn't know that, it's your parents' fault. And of course, we all know it's Bush's fault. So he takes that money and he puts it in the bank. And the bank says, now, we're going to act like you're Mr. Clampett, but you're going to have to keep it in the bank for 10 years. And you say, well, I don't want to keep it where I can't touch it. At least let me be able to pull some money. Okay, put it in the money market. You can draw 3 times a year out of it, okay? Or 4 times a year, or whatever. So you decide to put it in the money market. And they decide, keep it in there for 10 years. So T is equal to 10. And we're going to put it at 3%. So R is equal to 3%. And we're going to compound it monthly. All right, so go ahead and figure that up. See what happens at the end of 10 years with Mr. Pruitt's money.
What is A equal to again?
What?
What is A equal to again?
That's what you're finding out. That's I don't know what it's called. It's called the product, I guess you'd call it. I don't even know what it's called. You have to look in the book. I think it says it in there. I know it's what the money, the end, the outcome is. I can look it in the book and see. So that's gonna be 5.5 million times 1 plus 0.03 divided by 12, raised to the 12 times 10, which is what? 120? And then you take your handy dandy calculator. And we take the handy dandy calculator. And you can do this without even writing it down on paper. It's real simple. You take 0.03 and divide by what? 12. And then you add it to what? 1 Hubert. And then you raise it to the 120th power. And then you multiply by 5,500,000. And that's that number. And let's go ahead and subtract our principal so we know how much we made. 5,500,000. And that gives us that much, which we left it in there for 10 years, right? So divide that by 10. Comes out to be about $192,000 a year. I mean, could you? How many of you could live off $192,000 a year?
Shoot, yeah.
I could. Yes, sir.
So like, that's no taxes on that, no, that's just straight,
Well, it depends on where you put it.
okay.
That depends. That's why you need an accountant. So why he's leaving that money in there for 10 years, or for 5, or for a year, whatever. He's talking to a lawyer / accountant that's licensed both as a lawyer and an accountant to find out what to do with that 5.5 million. He's not going to the strip club in 3 different cars with the console with $500,000 in each console. That's what the guy in Texas did. Except he didn't take all 3 cars to the strip club. He took his truck to the strip club and it got stolen at the strip club while the other 2 were stolen out of his house
Oh my gosh.
with $500,000 in the console.
Did he buy a new house?
Huh?
Did he buy a new
I
house?
don't know. Probably lived in a trailer knowing this guy. I mean, he wasn't too bright.
How many rental properties do you think you could buy?
Oh my gosh, there's no telling. Depends on if you get them tax foreclosure sales or not. But now, this is exaggerated, of course. I'm exaggerating a little bit, but you're also talking about $5,500,000. You know, and it might be a lower percentage. I don't know what the percentage. I'm just using 2 to 3%. But you'd have to talk to the local bank. But that is that's behind this. Where is it? Right here.
Do banks seriously like pay your bills and stuff?
What they would do is take out a simple interest loan or take out it's called where you don't have to put up collateral. Can't remember the name of it because I've gotten them before with like tractors and stuff. And they just pull out a loan and they use what you've got in savings or whatever as collateral. So let's say if you skip the country and you borrowed $5,000 to buy a car. Well, they got that money year tagged in your savings account, $5,000. They're not touching that money. They're letting you borrow that money. And if you kept your job, let's say you kept your job working at, I don't know, White Jones or whatever, and you could make those payments, or you could get them to take the payments out of the money and it would go toward that loan. You see what I'm saying? In other words, unsecured loan. That's what it is, unsecured loan. In other words, you could pretty much do whatever you wanted to. They wouldn't pay your bills like not take it out of your money. No, they're not going to do that. But what I'm saying is they would not let you go without just because you wanted, instead of $5,500,000, you say, well, I'll just put $2 million in there because I need to live off. No, we'll take care of you. In other words, they want that money in there. And they would do anything they could to keep you from taking that money out. They would rather you take it out a little bit at a time than to take $2 million out and put it in another savings account.
Unless you be like Billy Ray Cyrus going through the drive-thru at the bank trying to withdraw $1 million.
No comment.
Thinking that they'd give it to him.
He doesn't register for me, I think there's an idiot behind it. Anyway, sorry. And they go through and tell you how to do that. What is A anyway? What does it stand for? Does it say? I'm sorry, what?
It's the accumulate.
Okay, accumulate.
The amount that you have after so many years.
So why don't they just call it that?
I
Okay.
don't think they want to write all that, amazing.
So we just saw it for what the bank made, not what the actual guy made.
No, that's what you made.
That's what he made.
Yeah. Okay, now this guy right here this right here makes you sick. This right here, if you took the 103, it makes you sick. Does anybody know why this one will make you sick?
It's 10.
It will make you sick because you actually find out how much money you spend when you buy a car or a house. So let's look at this one. Now I'm going to rewrite it, okay? This right here is 1 over I. They give you I negative n. Negative n again is, but I'm going to change this right here. I'm going to rewrite this and I'm going to put this over 1 and I'm going to flip it. So I can change this right here to a positive n. So they're going to give you that. Okay, so let's do this one. I like to tell people to do this right here, not for the grade, but so you can use it in real life, because after you see it, you're going to be like, oh, okay.
I think it's
Thanks
funny.
for telling me that, Hubert.
I think it's weird that they put the period after the formula.
I'm not even looking. Hold on a minute. I want to pull that out. I don't want to rewrite that. Oops. Okay, so let's take this guy. There he is. And the only thing I'm going to do different is I'm going to rewrite it, because I don't like the way it's written. I'm going to take, you see this right here? This right here is over 1. So I'm going to rewrite it. R is equal to P over 1 minus, and I'm going to put this over 1. 1 plus I to the negative n over 1 all over I. This bottom part is over I. Now, I'm going to flip this right here. Why am I going to flip this? Because if I flip this, it'll make this negative n what? Positive n, and it won't give you a conniption when you see